Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Moore's Algebra 2 class. Today we're going to wrap up quadratic functions, graphing them, solving them, finding the solutions via graphing or algebraic. We're going to wrap it up with learning how to solve quadratic and rational inequalities. If you remember, inequalities are not the same as an equation, okay? Give me 1 second and we'll get right back to you. Alrighty, guys, sorry about that. So, there are two ways of graphing inequalities, okay? Quadratic inequalities. Graphically and algebraically. Now, if you're going to solve it graphically, you solve like normal. Find the axial symmetry, find the vertex, find the y-intercept. You can find the x-intercepts if you want. Go ahead and find their mirror images. You graph it, and then you got a shade, okay? Now, the shading is where it gets a little bit tricky. Sometimes you think it's going to be one way, but it's really another because you have to test solutions. So there's nothing new to the graphical method except the shading. And the only way you could find out what the shading is by solving it algebraically. So I'm going to show you how to solve algebraically, and then I'll show you what that means on your actual graph if you were to do it graphically. So if I tell you to solve x squared minus 4x minus 5 is greater than or equal to 0, okay? The way to solve this is really just by finding the actual solutions. Where is it going to be shaded? Because if you remember, in inequalities, there are a multitude of answers, not just one answer. So you're first going to write the inequality in standard form and set it equal to 0. So pretend that you don't have a greater than or equal to sign, and just go ahead and go x squared minus 4x minus 5 equals 0, like it was a normal quadratic equation. Next, solve the equation. Solve the equation? What do you mean, Moro? Well, we can factor, complete the square, use square root method, or the quadratic formula. We have these skills. Yes, sir. Now, I'm absolutely going to try to factor always first, and in this case, it works for sure. Got negative 5, positive 1. Now, zero product property, x equals 5 and negative 1. Is everyone with me so far? Okay, now, step 3. Plot the solutions on a real number line and test each interval in order to find the sign of your original inequality. Please remember that a negative divided by a negative is a positive divided by a positive is a positive, a positive divided by a negative is a negative, and a negative divided by a positive is a negative. Okay. What does this last part mean? Let me explain very simply. You're going to create a number line. Put 0 in the middle always just to give yourself a reference point. And then put the 5. And then put the negative 1. Okay? What I just created are 3 different test intervals. This is my first interval. Between negative 1 and 5 is my second interval. And to the right of 5 is my third interval. And these are my test intervals. And I have to test to see if this works. Test to see if this works how? I have to test to see if x squared minus 4x minus 5 is really greater than 0. Okay? But I'm going to make my life easy. I'm not going to plug my test values into this function here. No way. I'm going to plug it into here. Because look how much easier this is. You already have 2 simple little products. You don't have to square anything. So, what's a value to the left of negative 1? Negative 2. Okay, so let's plug it in. Negative 2 minus 5 is negative 7, right? So that's a negative 7. And negative 2 plus 1 is a negative 1, correct? Okay, is a negative times a negative a positive? Is it supposed to be a positive? Is it supposed to be greater than 0? So then this works. And I got a little trick for you guys. If this works, this will never work, and that will always work. I'll prove it to you. When x is 0, what's 0 minus 5? Negative 5. What's 0 plus 1? What's negative 5 times 1? Is negative 5 greater than 0? So that's why this guy doesn't work. Let's go to the third section, which I said had to work already. A number greater than 5 is, what's 6 minus 5? 1. What's 6 plus 1? 7 times 1 is? It's a positive. Positives are greater than 0, so that one works. So my solution is from negative infinity to negative 1, it's greater than or equal to, bracket, in union with bracket 5 to positive infinity. Okay? Now, what does that mean on the graph, Moro? That's all fine and dandy, and that's great. What does it mean on the graph? Okay, let me show you. Because I want to make sure you guys get this really well. If I wanted to graph this, guys, well, first of all, I know my x-intercepts, right? It's 5 and negative 1. So I'm going to go 1, 2, 3, 4, 5, negative 1. Real quick, guys, what's my y-intercept here? Yeah, when x is 0, y is negative 5. So that's 1, 2, 3, 4, 5. Now, before I do a mirror image, I need a vertex. Okay? So my axis of symmetry here is x equals negative b over 2a. So x equals 2. So that's my axis. And then my vertex is my y value when I plug in my axis of symmetry x. So 2 squared is 4. 4 minus 8 is negative 4. Minus 5, negative 9. So that's right here. So my y-intercept is 2 to the left, go 2 to the right. And now this is greater than or equal to, so it's a solid line. If it was greater than or, oh boy, what did I do there? If it was greater than or less than, what did I do with my graph? What did I do with that thing? Ah, did I really just lose it? Okay, well, okay, we'll do it again. Sorry about that, guys. I don't know what happened there. All right, but you guys can help me out. Give me the values that we already calculated, please. Axis symmetry was 2, right? 2, negative 9 was my vertex. Negative 5, 1, 2, 3, 4, 5. So that's 2 to the left, so go 2 to the right. My x-intercepts are negative 1 and 5. 1, 2, 3, 4, 5. Okay, so like I was saying, if it's greater than or equal to or less than or equal to, it's a solid line. If it's greater than or just less than, it's a dashed line. So you have this here. And now, here's the thing. If you did not know that my solutions are this, would you really be honest? Would you really know how to graph greater than? Where do I shade? Do I shade above the vertex? Do I shade outside of the vertex? That's where it gets very tricky. For a linear equation, it's easy. It's either above the graph or below the graph. But in here, we have the inside part of the graph, okay, and we have the outside part of the graph. Well, that's why this is so important. What is this telling you? It's telling you that the solution are from negative infinity to negative 1 and 5 to infinity. So what does that tell me? That it's shaded on the outside. And that's how you graph this. For our intents and purposes, when I say solve, I only want you to solve algebraically. I only want this answer right here, guys. I promise you. But as a teacher, I need you to know and understand what that means. Okay? And what that means is I shade it on the outside because my valid values are from negative infinity all the way to negative 1 and from 5 all the way to positive infinity. So all of this on the outside is a solution. Does that make sense, guys? Promise? Okay, now let's get back on track here. So we did number 1. Okay. All right, so let's do this. So again, guys, we do not, I don't want to be a broken record, but we do not have to graph these. But in a pinch, if I tell you to graph this or an SAT or an ACT tells you to graph an inequality, you do like normal. Find the axis, find the vertex, find the y-intercept, plot all those points. If it's greater than or equal to or less than or equal to, solid line. If it's greater than or less than, dashed line. And then where do I shade? You do it algebraically. But for us, we're just going to do it algebraically. Okay, me guys, when I'm finding solutions and whatnot, I like to work with positive coefficients of x squared. So I'm going to move everything over there. So I'm going to have 0 is greater than x squared minus plus 3x minus 10. So I'm going to go ahead and factor this if possible. So I got x plus 5 and x minus 2. So x will equal negative 5 and 2. Okay? Let's go to my number line. Here's 0. Here's 2. Here's negative 5. Now, how many of you guys would love to learn a trick right now where you never, ever have to use a test value ever again for quadratics or absolute value? Okay, only half of you. The rest of you want to do the long work. Okay, cool. I'm going to give it to you anyways, though, for those of you that don't want to do the extra work. Guys, you can totally go ahead and set up your test intervals because there's not a darn thing wrong with that. Not a darn thing, okay? But here's the trick, guys. Whenever it's greater than or less than, think of this. If I have a greater than or equal to, think of it as this. Greater. Do you remember that the OR equations, guys, were like this? That they went away from each other? Well, guys, that's the way the solutions will always work with a greater than. So whenever it's greater, I don't even test it. I know immediately it's greater, then that means this guy and this guy are going to work. So my solutions are negative infinity to negative 5. Parentheses. Why parentheses and not bracket? Because it's greater than, not greater than or equal to. And union with 2 to positive infinity. So whenever it's greater, it's the outside solutions. Greater, or think of an OR inequality, and an OR inequality, remember, they're separated. They go away from each other. Bless you. Okay? Greater. But wait. Here, this is not greater though. Is it? This here is less than. So when you have a less than or equal to, think of it like this. Less than. What does an and inequality look like? Yeah, it's between. Like let's say I have it here. It's right in between. So greater, you're looking at the outside solutions. Always 100% of the time. Less than, you're looking for the inside solutions. So since this function, remember you read from the function out, is less than 0, my solution here is negative 5, comma 2. Does that make sense? Promise? And what that means, guys, is that in this graph, it's negative, so it's probably going to be like something like this. It's going to be shaded inside between the negative 5 and the 2 because it's a less than. It's going down because it was negative. Okay, does that make sense? Okay. Now, next. So greater and less than really, really save a lot of time. Next. Okay, I've got here 0. I got x squared plus 2x minus 24. I'm going to go ahead and factor to find my potential zeros here. What times what is negative 24? But when added together is positive 2. Positive 6 and negative 4. Great. So my x equals negative 6 and 4. So that means that I have negative 6 and a 4. But this function, is it less than or greater than 0? Less than, and. So I know if it's an and, it's going to be this guy right here. So my answer is negative 6, comma 4. Is this not like amazing, guys? Super, super quick, and you never have to test a value again. And again, you can prove it. If I go this way, I choose negative 7. Okay, negative 7 plus 6 is a negative 1. And a negative 7 minus 4 is another negative. A negative times a negative is a positive. A positive is not less than 0, so that does not work. If that one doesn't work, that one will never work. The middle has to work. But we don't have to test again as long as you remember greater or less than. But that only works. It only works It only works with quadratics, so that's when x is squared, or, believe it or not, absolute value. Whenever you have an absolute value or quadratic inequality, the greater and less than always works 100% of the time, my brothers. Okay, I got 2x squared plus 5x is less than 7. So I got 2x squared plus 5x minus 7 is, man, I want to do a greater than. Let's do this as a greater. Change it, because they've been less than, greater than 0. Okay, now let's see what we got here. Okay, this is 2x. My new c is negative 14. What times what is negative 14? But when I add it together, it's positive 5. Positive 7, negative 2, very good. Imaginary factor. I got 2x plus 7, and x minus 1 is greater than 0. So that means that x is equal to negative 7 halves and positive 1. Make my number line. Here's my 1. It's my negative 7 halves. And this is a greater. So OR functions are separated. So it's this guy and this guy. So my solutions are negative infinity to negative 7 halves, union with 1 to positive infinity. Sir, my brother. No bracket because it's just greater than, not greater than or equal to, sir. Thank you, my brother. Thank you, my brothers. I flipped the sign because I wanted to, because we continue to do less than. I wanted to change it and just rewrite it with a greater than.
But you could have done less.
Well, if I left it as less than, it would have been in here.
Yeah.
But I wanted to change it up, and I just changed the whole question from the beginning. No worries. Thank you, my brother. I was just tired of getting less than. And then now this one, I want you guys to really pay attention to this, because this one's pretty cool. Okay, when I factor this is going to be m minus 4 times m minus 4, okay, is less than 0. Well, in this case, m only equals 4, right? Huh, that's weird. So you got your 4. So it's either to the left, to the right, or itself, okay? Now, this is a less than. So it cannot be the or. It can't be on the outsides, right? It's a less than. So the only thing in the center here is what, though? 4. Well, let's see if 4 works. If I plug in 4 here, guys, what's 4 minus 4? And then what's 4 minus 4? What's 0 times 0? And is 0 less than or equal to 0? So my only solution here is only 4. Yes, sir, my brother. That graph would look like this, my brother. Here's okay, my axis of symmetry is going to be negative b over 2a, so x equals 4. My vertex is 4, 0. My y-intercept is 16. So it's going to look like that. But then it's only 4. So I can only shade this point. No other point is valid. No shading there because it's just one point. Yes, sir. So this would be, in this case, the answer would be 4. Yes, sir. That's exactly right. Now, okay, guys, listen up. This is not your fault. This is nobody's fault. We've had a great day. We have to learn rational inequalities. We will do that tomorrow. Okay? Listen, he's going to delay us. Please listen to me. This is on a recording. Okay? We're going to have the test. I'm going to have to postpone it to Monday. I know that Monday is a very dangerous day. Monday is very dangerous because you're one day away from spring break. Please listen to me, and I have this as a recording that I will show your parents. Okay? If you choose to take an early spring break and you miss my test on Monday, you have my word of honor that the day we get back from spring break, I will give you the test that day. Not the next day. I'm not going to give you, oh, sir, I got a review. You will take it that day. So I'm begging you, I'm pleading you, I'm praying to God that you're taking me seriously. The test will be on Monday. Be well. Go over this. Thank you. God bless you, and I hope you learned a lot. Bye-bye.